All right, so for this assignment, you had to rig a robot, basically. So to take separate parts of the robot and put together in the hierarchy. So let's start with the review of the assignments first, and then we'll do the lecture. Okay, so let's start from top down today, and then next time we can go the opposite direction. All right, so Sophia first. So let's see, there is a video. What did I do? Share screen. Okay. Apologies, I'm working with a single screen today, so there you go. Okay. All right. So I looked at all your videos before class, and I think they're good. They're all good. So this kind of shows all the controllers of the robots. That's really great. So when kind of creating videos like that, so I think what you're doing here is good because you're kind of placing the robot in a pose. But when demonstrating a rig, it's good to kind of show more broad movements, right? To show that, look, we can move this robot a lot, we can rotate this leg a lot, and so on. For this assignment, it's not that important. But when in the future, if you ever want to create a rigging demo reel, so that's something to keep in mind. Okay, so it's difficult for me to tell here if the fingers, so it looks like the fingers are not rigged in the way where they can all be moved apart, but that's okay, that was an extra credit. All right, so let's fast forward a bit. I really like that you worked on the eyes and made sure to parent those parts together and even on the eye pupils. So that's really good kind of attention to details there. Okay, and that's the left hand, right? Okay. So with the left hand, it looks like they're oriented differently, right? From the right hand. It looks like on the left hand, they're oriented where they can go, kind of spread out. No?
They kind of both are. I wasn't able to, so I had two problems with the hands. I wasn't able to figure out how to get it so that the fingers could move like as a group, like all move out together at the same time, and also be able to move one at a time. So I settled for one at a time. And I wasn't able to change the orientation of the pivot, so I could make it so that the pivot was in the middle of the ball where it rotates from, but I couldn't change the orientation, so you kind of had to like pull down the middle of the two rotations.
Right. Yeah, we'll take a look at how to do that later. Yeah, but overall, I think this looks good. So everything. So from this video, I can see that everything moves well. Okay. So then there are images of a robot in the pose. So there's this one, which I really like because you added like some props. It's really cool. The angle looks a bit odd to me. It feels like for this kind of shot, you would want the camera to be positioned a bit up. But overall, I think this is really nice. This really shows the character. And this one I think is also really great because it kind of shows him thinking, and also the fact that here every every piece of geometry is moved. So that's great. And I'm not an animator, so I won't be critiquing your poses, how the weight is distributed in the character, nothing like that. For me, all it matters is that it showcases that the rig is really usable. And I think this is a very good showcase of that. Okay. So this is good. Now let's look at the file. So the first thing, so I like that everything is in one group that we can expand, and that we start with the T-pose. So when you're giving an animator your rigged character, you want it to start from the T-pose. All right. So let's start with the body. So for the body, I see you kept the pivot point here in the center. So that's good, that's fine. So for the body, you could have done multiple things. So you can place the pivot point here or sometimes even here, but center is a perfectly good way. And then these are the legs of the robot. Which move well. Let me make sure as I'm moving that I'm checking the attributes. Okay, so all of this is good. Let's check the arms now. Something like this. And these are the fingers, right? Okay, yes, so the left and the right are oriented the same. I thought they were a bit different on the video, but this makes sense. Okay. And then something like this. Okay, nice. So this I think is really good. All the points of the assignment are used. Well, so actually the only thing for me would be maybe I would make the pivot of this head a bit different. But then it's an odd shape, so it's kind of tough to know how to use it. But I think, yeah, I think the idea is that it would wobble like this. And for that, it's perfect.
I actually, looking at it, the shape of it, like, to me, I thought that it was kind of like, you know, Star Wars R2-D2, where his head kind of goes side to side, but it doesn't move up and down very much. So, like, looking at it, that's kind of what I saw, but I can see like, vertical movement, how that would not be very, very well rigged for that, but yeah.
Right, I guess because I'm seeing like that there's still geometry there, maybe they meant for it to kind of go out and wobble around. But those are minor details. Since you didn't know specifics, I think kind of making it just work like this and having a little bit movement here is perfectly fine for this character. Okay, great, thank you. Any questions?
No, the only thing I have is just the finger thing, but if we're looking into that anyway, I'm good.
Okay, great, thank you. All right, the next is Shantae, and I believe it's this one. Okay, let's first look at the videos. Oh, there is no video, so images. Okay, so then there's
a video, but it was too big to upload, so I put it in the comments. I put the link to it in the comments.
Ah, okay. Can you please compress it and upload it? Because then when I'm grading, it's good if I see that there's a video. You can compress it using QuickTime. If you have QuickTime, you can do it like that. If you don't, there is a free software called Handbrake. This one. So that's what I usually use to compress things on Windows. So hopefully that would help.
Okay.
All right, but for now, let's take a look at the images. I guess that's great. So you did the extra credit of posing Morpheus. That's great. And there he is again. And that's the robot in the pose. I think this is also great. And I like that you even, you either lit it or is it viewpoint 2.0, right?
Yeah.
Is it? Yeah. Yeah. Well, it looks nice. And So one thing is that it looks like the head and the body are not moved in this pose, which makes it look a bit like stiff and static. So I think if you were to move the body and the head, it would both make the pose a little more interesting, and it would also show that you worked on all of the parts.
Okay. I think it might be the angle that I did it at, because I did move the body, like I tilted the body a little bit. Well, I turned it and I turned the head to the side, but I think I got it at a weird angle.
Oh, I see. Yeah, so maybe it's just, or maybe just very slight, so I didn't notice it. Okay. So that's the images. So let's now look at the file itself. So my first note would be that when you're kind of giving the rig to someone to use, to an animator, you don't want it to be in the pose. So even if you're testing it in a certain pose, you then want to zero out all the geometry. And that also brings me to the fact that right now, all of the geometry is zeroed out in this position. So if you're assuming that an animator will be just using this geometry, then you don't want it to be you don't want it to be zeroed out. Sorry, in the pose. You want it to be zeroed out when it's in the T pose.
Okay.
Because so the reason for that is that way animator can quickly set all the parts to 0, and that would bring back to the T pose. Okay, so here now looking at each part, let's see. So the body, so the pivot of the body would make more sense to put somewhere in the body, right? Because when if animator is moving the body, they wouldn't want to do it from the origin. Okay, also looks like, okay, so there is a hierarchy in place. Okay, so you grouped it, right?
Yeah.
So for this assignment, kind of the idea is to parent it to geometry. So kind of the theory behind it is that animator is kind of animating the geometry itself. So then if they were to use this body, they would want it all to follow the body. So right now you're kind of doing that with groups, right? So you have your upper body group, and you have this all this part in the group. So that's great, but that would make it impossible for an animator to use those groups because they can't easily select them.
Okay.
Okay, so yeah, so that's kind of my note for all of these parts, really. So they should be like connected one to each other. All right, so then as for pivot points, so yeah, so also I would change all of these pivot points. So right now, so for example, the pivot point of this group is correct. So it's rotating from the shoulder. But it's difficult to know what are you supposed to be moving, to be rotating. So the idea is kind of to have all those parts to have the same pivot points. So for example, for a forearm part, it would be the same as for the forearm group, and so on. Okay. And so then, okay, and so the fingers might be correct, but because kind of the idea is to rotate them from geometry, to find a way to rotate them from geometry, this is also kind of not complete in that sense.
Okay.
All right. Okay, so that's all the comments I have for this rig. Any questions?
No, I tried to upload the video just now, but it looks like the compressed folder is still too large.
Okay. Well, it's okay. It's you can, like, if you can do it until the end of the class, that would be great. If not, if you even have some animation of it, maybe you can play blast it and place in the folder. So I'll be grading it after the class ends. So you have until the end of it to upload it. All right, so that's that. Let's see, Hunter. Okay, great, the robot in the pose. Okay. I would, so when posing, just as a general note, I would try to avoid foreshortening because it's difficult to read the pose this way. Okay, let's see now my.
Sorry, it also uploaded in the posed position. I have a separate file for the unposed one, but I'll upload that later.
Okay, sounds good.
It's still all mostly done.
All right, let's see. So there's the body. Yeah, so again, so the same note for this one. So the pivot point of the body, I would place somewhere at the body. So either at the base of the body or in the center or maybe at the top. But at the origin, it makes it kind of difficult to use it as the root, right? So usually rigs actually have two pivots. There's one at the base and one at the root, so that you can move the character from the root.
That's mostly what I was confused about, because I'm pretty sure I've seen some pivots that start at the feet and then some in the body itself.
Right, right. So usually you want to have both. Yeah, that is a good observation. All right. So then the legs. Oh yeah, so with this one, so because the values are not zeroed out, we can probably zero them all out here and it will go into the T-pose. So we can test it this way. Okay, so there go the feet. So these look good. And this one also looks good. The head move a bit. That's good. Oh, that's right. There are two parts. I forgot. Yeah, so this is.
I wasn't really sure what to do with that part. I wasn't sure whether to parent the main arm to that little tiny part or to parent that little tiny part to the main arm. Because it kind of looked weird when I just moved the arm, or like when I tried to move just the arm and then the little part didn't move at all. So I went with the one that looked a little better visually.
Right. So this is an option, but this doesn't work very well if an animator kind of wants to just move everything starting from the shoulder, right? Because so you want to give an animator as much control as you can. So the idea here is that this is kind of a socket, right? And this part should move inside of this socket. Right, so if they want to move the socket itself, we can still give them an ability to do that, but you want to also give them an ability to move the ball inside of that socket. So as a solution for that, it makes more sense to parent the socket to the body and then parent this ball that is the beginning of the arm to the socket. So this way, so the animator can still move the socket if they want, but they can also move this arm independently. And I think the reason why at this point it doesn't look very natural is because the pivot point is not at the center of the circle. So just as a reminder, you can find the center of it by placing a cluster inside of it, right? It's a bit of a trick here. So you can go to the form cluster, and now I'll put it on the layers that I don't accidentally snap to geometry. So I'm holding D, and now I'm holding V to snap the pivot. So now I'm snapping the pivot to this cluster itself. And now if I rotate the arm, it rotates kind of more naturally inside of this part, right? And now that does it make sense?
Yeah.
Right. So now that this is done, it's important to delete all the layers so that we don't leave any trash around for an animator who would be using it, and any leftover clusters that we used. Okay, so that's for the arms. So this part also, so you can use the same trick to kind of find the more exact center of this mass. So you can find, for example, the center in between these 2 points, and that will give you an idea of where the pivot point for this part should be. Okay, and the wrist actually looks fine to me. Oh no, it intersects a bit. So I guess then the same thing for the wrist. If you find the exact center, it would look better. Okay, and then we have the fingers. Okay, so the fingers look fine, but again, we'll take a look at how we can make them all kind of, when we select all of them and move, so that they move apart together. All right, let's look at the face. Geometry, okay, so we have this part that rotates, have this part that can wiggle around, the brow part. This thing, okay. And then this eyeball. Nice. All right, let's make sure it's all working on this side too. Yeah, for the eye itself, also, so right now, if I try to rotate this part, for example, it kind of, you can see it kind of starts intersecting the mesh. And again, this can be fixed by finding the center of this ring and placing the pivots there. And yeah, and kind of the same thing goes. So it looks like the pivots for both of the eyes are a bit different. So it's better to be consistent of where the pivot point is for each part of the body. And so in this case, also, so you can see how the eye is not really rotating around its axis, but instead you can sense that its axis is, well, here, like, so not in its center. So again, if you find the center of the circle, that would fix that issue too. All right, so that's it from me for this rig. Any questions?
Oh, actually, what's the cluster button again?
Oh yeah, it's in, so you have to select the vertices that you want to find the center of. You can select, for example, the ring by clicking and then double clicking. That selects the ring. Then you go to deform and cluster, and that creates.
Okay.
Yeah, and so we'll be talking about deformers probably later in this class. I'm actually not quite sure if this is part of this curriculum. If it's not, you'll be talking plenty about them in the intermediate rigging class. But so different deformers can be very useful. They're usually applied after the rigging is done. But in this case, we're just using this cluster deformer kind of as a hack, kind of as just a trick to find the center of selection.
Thank you.
Of course. All right. And then, okay, so there was, did we look at the image? Yes, so it was this guy. Okay, so now we have Tatiana. So let's look at the images first. That morph is great. I like both the pose, and I like that he's interacting with a prop and another prop, a ladybug. And nice. And I also like that here there's environment too. It like really gives character, creates a story. And also I like that the pose is very kind of pushed, so you can see all the parts of the rig are moving, and it's very clear what the robot is doing. Yeah, so again, here I would avoid kind of these foreshortening angles with the hands, so it's easier to read the silhouette if it's if the arm is kind of positioned differently, or if the camera is positioned slightly differently. But this is great. Okay, and this is the same robot in the pose, but from different angles. Okay, this is great. Yeah, good to see that too. Okay, let's now look at the video. All right, so yeah, so it's if I can tell right, it's a play blast, probably with all the parts of the robot moving. So this is good. So sometimes we do want to demonstrate a rig by kind of playing all the parts. It's also quicker to see it that way. For this class, I would prefer you guys to kind of keep it to actually recording yourself moving the parts, because that way I can better see how everything is oriented. If you are doing something like this for a demo reel, then it's better to do it a bit more sectional. So usually in this, these are sometimes called calisthenics, I think. So usually you would have, say, him moving his arm, then like moving the wrist, then moving the leg, but kind of sectional, so that you can see, so it's clear what is the point of view, right? But this is also good. It's great that I can see all of the motions that the robot can do. All right, now let's look at the rig. Okay, let's start with the body. So yeah, so I like that the pivot point is here at the bottom. It makes it nice and easy to rotate. Okay, let's see. That's the leg. The top of the leg is also accounted for. That's great. That socket. Okay. And the feet are also looking good. Now let's check the arms. Okay, so that was a good placement for the pivot. This part is also moving. This arm, and I looked at this trick before. I believe here the fingers, you actually figured out the trick to have the fingers oriented correctly, right?
Yeah, it took 3 days of my life.
3 days.
Yeah.
Well,
I was dreaming about these fingers, you know.
Nice. I'm happy that you figured it out, though. It's better than if I were to tell you all how to do that. Okay.
Yeah, I was really happy when I could. Yeah.
Nice. Okay. So yeah. So right now fingers are oriented kind of in a way where we can easily move them apart. Right. So if we select all of these parts, they'll move like so. Select all of these parts, they'll move like so, and so on. Okay, so the way it's achieved is also the way that I would show you guys is through groups, right? So here, the orientation is, well, let me Let me zero it all out. So here, each finger has its own separate group, and then there are rotation values on the group. So when we have a rotation value on the group, the child of the group, the child of any object, can inherit its rotations, right? So if we have rotate x set to 45, this geometry, it won't have values of its own, but it will be oriented as if it's rotated to 45. And in this case, we can also do it for all parts of the finger. So that would give it an even smoother result. And then as for these fingers, so in this case, they all have the same value from what it looks. So if we move them all together, excuse me. So if we move them all together, they kind of rotate in the same direction.
Yeah, I didn't check that. My
Right.
brain was not enough. Yes, you can calculate.
But
Like
that's
45 minus 45, yeah, like this.
right, right. So you got the
Cos.
principle. So yes, so we can pretty quickly change that. So
Yes, yes.
so if we just and I think minus 45 will do here. So now well, we would want to freeze all of these transformations, but the idea here, okay, let's check again. So this was set to 45. Let's set this to 0 first. Okay, so this is minus 45. So we actually want it to be minus 45 minus 180. So that's, sorry, let's do it here. Minus 45 minus 180 is minus 225. So let's do that. Okay, so now we can rotate this finger back and freeze its rotations. We didn't really talk about how to freeze things, so we could have just rotated the group and then unparent and parent things back. But now it should work. So now we rotate by the same axis, but it's plus here. And then it's minus here. Oh, this doesn't look quite right, right? Because this is y. Y axis. And this is z. Okay, so it doesn't look like I changed it right. Let's copy this group. Let's duplicate it. Let's place it here for now. Okay, so now it will be the same. But we want this to be at minus 45. Okay, so now if we rotate this group down. Let's parent the fingers to it. Now let's freeze all the transformation. Okay, so it's y plus here and y plus here. Okay, so now if we're to rotate these two together, they will rotate in the opposite directions. So yes, sorry if I made this all sound maybe more confusing, but the idea is that we want to change the groups over the geometry. And you can even do it, you can even kind of eyeball it if you want. And by eyeballing, you can kind of find the exact numbers. So if this one is, say, minus 45, then this one will be that minus 180 degrees because we want to flip it upside down. But that's kind of the idea. So so the kind of the trick here was to figure out that we can change the orientation of the object by rotating the group. Okay, does that answer this question for everyone? Does anyone have any questions? Okay. All right, so let's continue by looking at this rig. So then there are eyes. Yeah, so with eyes, you can go either way. You can rotate it you can rotate the people from the center, or you can make the center kind of in the center of the eye and then rotate it around. So this is kind of up to Animator how they want to use it. Okay, so then this looks good. This looks good too. And then the brow. Okay, and then the eye rotates also around itself. Okay, did we look at the head? I believe so. Okay, yeah, so the head works really well too. And it can move up and down. All right, great. I think this is really good job. Any questions?
Thank you.
Mm-hmm.
Yes. When I put the cluster and put pivot, snap it, then I snap the pivot of the group, for example, for fingers, and also snap the group pivot to the same cluster. In the end, I can see that if I change pivot, look at group pivot and the pivot of the element, it shows me like pivot is a bit moving.
So
why
a bit different.
So? Yeah, but they are snapped to the same cluster.
Were they snapped to the same cluster?
Yes,
well,
this is very strange.
Well, let's try it together. I think what might have happened that maybe it didn't quite snap to the cluster.
I tried maybe 10 times and checked and double checked that they're snapped together.
Okay, let's try. So let's, I'm selecting the circle, right? I'm gonna go deform cluster. I'll put all of this mesh on a separate layer. I'll first select this mesh though. Okay, so now I'm gonna snap it to this cluster. And now I'm going to snap the groups pivot also to the cluster. Right, so now they're snapped to the same object. Yeah. Now I'm moving between them and the manipulator stays the same.
Well, strange. Maybe it was something, sometimes there is a problem with Maya. So maybe I had to restart the program and I wouldn't see this little shaking.
Yeah, could be, but also it could have been that maybe when you were snapping, you accidentally were snapping to a different object. That's sometimes
impossible. Impossible. It was in isolation mode, only one cluster. So absolutely, you know, like surgery.
Okay. Well, so if it happens to you again, So another thing you can do to match two pivot points. So let's say we snapped the group's pivot, and now we want to match this geometry's pivot. We can select both of them, and we can say, where was it? Modify, match transformations, and match pivots. And so now their pivots will be the same.
And the pivot of so I wanted to match the pivots. So I found this option in Maya, but I didn't know which pivot will match to which pivot, because the group was still not, it was still like a null group, you know?
Yeah, so it's whichever object you select first. So the first object will match to the pivot of the second object.
Okay.
All right, let's actually double check. Let's double check that. So we're selecting this geometry first, then the group, modify, match transformations, match pivot. No, you know what? I think I lied to you right now. I think it's the other way around.
Okay, no problem.
So
I just changed the arrow here in my paper.
So it's first group, then geometry. I thought it. Group, modify. I think I was right the first time. Sorry about that. Okay, so this one is wrong. this one is right. This one is wrong. So we're selecting the wrong one, then the correct one, then modify, match transformations, match pivots. Okay, and now they're both right. Okay, so first the wrong one, then the right one, and then it will match them. Okay, sorry for confusing you.
Yeah, no confusion. Yeah.
Okay.
Yeah, that's great. Yeah.
All right, any other questions?
And I couldn't figure out how to understand where to put pivot in the fingers exactly. So I wanted to figure out the middle ring of the vertices, but it is sometimes a bit difficult to figure out in fingers because they are different. The sphere looks different from different angle. And for one finger, it looks like, oh, this ring is the best one. But for another finger, it can look like another ring is the best one, you know, like it's the second one.
Yeah, I would decide on the same ring so that it's consistent over all of the fingers. But you can also try different things, right? So you can try using different rings, or maybe you can even try the base of the ball and see what works better, see what creates the best movement, and then just stick with that for the rest of them. That makes sense?
Okay, thank you. Yeah, of course, I tried to, but I cannot see the difference for now. I see the difference when I put it at the top of the ball. I didn't like the result, so I put it. I thought it would be more natural to put it just in the middle. I tried different loops, and then I tried to put and I couldn't see much difference. Maybe because these points are too close to each other. One loop from another loop. So I was just writing down for myself on a piece of paper, like second ring from blah, 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 blah. and putting it in every finger, you know, like this.
Oh, I see, just making
because
sure.
I cannot memorize if I making that one finger, the balls are different in each piece of the finger, and then I cannot remember when I'm trying to make another finger.
I see. Yeah. Well, in case of the fingers, I don't think it matters that much. And in your case, they look good. So I think you did a good job. I would personally probably would pick this ring at first.
Yeah.
Because
if you look from this angle, it looks very natural. But from other angles, on other fingers, sometimes it looks like another loop is better.
Oh, I see.
From for fingers which are below, sometimes it, you see. And then it looks like, oh, maybe this ring is much better.
I see. Here I would still choose probably this one.
Yeah, I believe I chose the same one.
Nice, nice.
Yeah, okay, thank you.
All right. Okay. Any questions from anyone else about any of the assignments? No. All right. In that case, let's start with the lecture. Okay. So this is Morpheus rigs. So some of you posted for the assignment, and those were great. Now you can see, so for the assignment that you did with the robot, you use geometry in order to create a rig, right, to build the hierarchy. But in most rigs that you're using, you will notice that there are controllers that you're supposed to use for posing the character. And controllers are kind of a preferred way of having an animator use your rig. Now, in this rig, if we look at controllers, what node type is it?
NURBS.
Yeah, exactly. And specifically NURBS curves, right? Because they're NURBS surfaces and NURBS curves. So these are NURBS curves. So does any of you have an idea why we're using NURBS curves and not something else, not polygons, for example?
I believe it's good for rendering.
Yeah, exactly. That's the reason. That's the main reason. So polygons are going to be rendered if we're rendering the shot, but NURBS curves are not going to be rendered. So that's why it's really nice for animators to use them, and then we don't have to even turn them off. What could be other reasons?
The other reason can be that when we want to see the geometry itself, we can turn off the NURBS, but polygons we will see the mesh.
Yeah, that's another good one. So here we can turn off NURBS curves, right? And we can see our pose without the curves. Yeah, that's a good reason too. In general, it's good to have a separation between different types of geometry when we have a rig, a geometry, and cameras. So it's good that we can turn off and on all of those parts. Any other thoughts?
Yes, it's easy to create them.
True.
And
yeah.
easy to see them.
Yeah, exactly. And visibility is another good point.
You can change the color easily. Yeah.
Yeah, that's another good one. So in general, I feel like NURBS curves have been a convention for rigging for so long that all of these things, like changing color, having them be very distinct in the model, all of those are very good points. Okay, so I think that's all of the ones that I noted too. Well, actually, so another one can be that when you're creating scripts for your rig, you can create a specific script that will do something only for NURBS curves, right? So for example, you can write a script that will, I know, make all of them invisible or change their color or translate them somewhere. So that's another reason why it's good to distinguish them. All right, so you can see that here we can grab these curves and move them around, and some of the other curves will follow because they are connected in the hierarchy, and some of them we can move individually. Now, if I create, for example, a square here, let me move it out. So why do you guys think, and let me open it up in the hierarchy to give you an idea of how it's built. So why do you think this would be a bad controller?
Bad controller for what? For like for the whole rig? Maybe because we have angles here.
No, because this one also has angles. So there is some way in which a NURBS square that you create by pressing this button and the NURBS square here are different. Can you think of what that could be? No? So the difference is, and that's why I kind of open it up here. So when we create the square in the from Maya's menu through a create NURBS primitive square, it actually creates these separate lines. It consists of 4 objects. So if we try to grab this square, we will only grab a line if we try to do that. So if we are to try to grab this controller, we're selecting the whole control, right? Or this one. So this is also a square, but we're grabbing all of it. But here you can see, because these are separate objects, we can't grab the whole thing. So that's another important important thing to note about controllers. So they should be NURBS curves, and they should be consisting of one shape. Now the question is, how can we then create a controller that will consist of one shape? So one way, so how would we, for example, create a square like that? So one way would be to go to create and then curve tools. We can pick any curve we want. Let's do it with CV curve tool. So here we can switch to linear, and we can snap our curve to these points, and that way draw a curve in the scene. So once we're finished, it will create a square, so it's the same shape as this, but this one consists of just one straight curve, since we just drew it without kind of leaving the creation of this curve mode. Now, another way, which especially works well if you have, say, separate objects that need to be parts of one controller. So another way would be to parent shapes to the transform node. So right now that we created this square, we created these 4 transform nodes, each of which has a shape parented to it. So we can't see them by default, but we can go to display shapes, and we will see these shapes here. So this curve that we created only has one shape, but each of these objects has a shape of its own. So that creates 4 objects with 4 shapes. Now, remember last time we talked about the difference of different types of nodes and how we have a transform node and a shape node. Well, we can also have multiple shape nodes under the same transform node. So now if you remember, when we select something in the scene, it selects a transform node. So if, for instance, all of the shapes of these transform nodes were part of the same node, the same transform node, then we would select all of them when we're selecting the transform node. So we can pick a transform node by at random, and then we want to parent the shapes. Now in Maya, you can't just easily do that. So if we try to drag a shape here, for instance, it will create a separate node on top. So that isn't going to work. So the only way, I guess it didn't do. So the only way to really parent it is through scripting. And so this will probably be maybe the first line of scripting that you will do, definitely the first one we'll do in this class. And it will be mel script, and it will be just one line. So the command will be parent. So that's the command we use to parent one object to another, pretty simple. And we also want to put a dash. So a dash signifies a flag. So that's something specific to this command. So I'm going to put -r for relative, and then -s for shape. So that way we can parent one shape to another object. So if we now select this shape, and then we select this transform node, we can now press enter, and the shape will be parented here. So now if we want to select this line, both of these lines will be selected because both of these shapes are part of this transform node. And we can do that as many times as we want. So we can now select this shape, select this transform node, and then run the same command, parent -r-s, and it will become part of it too. Okay, and so now if we select any one of these lines, it will select the full square because it will select this node. And now we have a lot of empty nodes, so we can just delete them. Okay, any questions about that? No? All right. Okay, so in rigs, we will often see different shapes in the same, of controllers in the same rig. So sometimes you will see squares, circles, you will often see cubes as part of the rig. With cubes, you can create them kind of the same way as we created the square. But a trick for that is to first create a polygon cube, and now we can draw the shape of our cube by snapping it to all the points. So we can go to Curve Tools, EP Curve Tool, I'll check Linear. Again, let's make sure the wireframe is on, and now we can just kind of draw over our cube. Okay, I'm not sure if I drew over everything. No, I made one gap. So mine is not a completed cube, but so if you want to do it better, you can put it on a reference layer and then kind of draw around it, then it will be different colors. But that's kind of the idea of how you can do that. And you can do it with all different shapes. So you can do it with a pyramid, with a cube, with a torus. So anything can help you draw your curves. Okay, so in this case, you can see it's mostly two shapes here, circles and squares. And usually when we use different shapes in the rig, they symbolize something. Not all the time, but a lot of times different companies have different conventions for the shapes of their controllers. And most times, the square or cube looking controllers are responsible for translation, so translation and rotation. And the circle ones are responsible only for rotation. So again, that's not always the case. In this case, for instance, we can still translate some of these controllers, but we can't translate this controller, for example. That doesn't do anything. Okay, and then you also pointed out the color. So color is also a nice way to distinguish different parts of the rigs. So of the rig. So oftentimes you will have controllers on one part of the rig be one color, and on the other part of the rig be another color. So for example, blue on the left side, red on the right side, and then yellow in the center. That's a pretty common way to change their color. And the way you would want to do that is you would want to go to, so first you would want to select the shape of your controllers. So let's actually use it with this one because there's just one shape. And then you'd want to go to the attribute editor, object display, drawing overrides, and then you want to enable overrides. And here you want to select a color. So in this case, you can select blue and the controller changes to blue. Okay, so in this case, we did it to the shape. Now, do you guys have an idea of why we wouldn't do it to an object itself? Because we could. So we can, so now I'm selecting the object itself, not the shape. Clicking Enable Overrides and changing the color to red. So why do you think is this better than this? Anyone has an idea? So in this case, we're changing the color of the transform node itself and here of the shape node. So the way mine works is that if we now to create a third controller and say we want to parent it to this one, it stays the same. Because this controller itself, its transform node is not responsible for any changes to the color. But with this controller, if we try to parent it, so usually this would change. Oh, sorry, here I changed the shape, not the controller itself. Yeah, so nurse controller shape. What I wanted to do is go to display, drawing overrides, enable overrides, choose red here. And you can see both of them changed color. So now if this one is unparented, it has its default color, but as soon as we parented it, to the node that has a color assigned to it, it changes the color too. So that's because of how parenting works in Maya. So it takes on all the attributes, including the color. So that's why it's important to keep in mind to change the color of the shape and not of the actual transform node. All right, any questions about this?
Wouldn't that technically be a useful, I don't know, function, I guess, if you're trying to figure out which shapes are parented where? Or like if you have a piece and you're trying to figure out what's parented to it, you could change the transform node's color. Like that has a function technically, right?
Right, yeah, so it's a good point because it, like, as you say, it feels like it could be a useful feature, right? It's like, oh, it's cool, you can parent them to each other and they will all change the color. So for example, here in the arm, if they're all parented to each other, it could be useful for all of them to change color, right? So the thing though is that when rigging, we want a more precise control. We kind of want a precise control over each part. We don't want it to change color without us kind of telling it to change color, right? So because we might think that, oh, all of those parts will be the same color. But then say we add some kind of extra controller like this purple one, and we still want it to be parented there, but then it changes color too, and then we have to kind of override it. So it just creates for a bit of a kind of messy view of everything. You still can do that, but it just later on becomes kind of difficult to troubleshoot because, oh, some controllers, the shape is changed, some controllers, the node itself is changed, so it's better to stick to one. And since changing the shape color allows more functionality, it's better to just stick to shapes. Does that answer your question? Okay, cool. All right, so then another useful tool to note for the rigs is a picker. And usually in the intro to Maya class, we look at the picker. I don't have it here yet. I don't have it here in the scene. So Morpheus comes with a picker, so you can take a look at it. So that's usually a separate UI kind of on the side of your character where you can press different buttons and that will select different controllers. So it's not that one replaces the other, but oftentimes once you're done with the rig, it's nice to give an animator an ability to use a picker. Or sometimes Nanometer can create a picker themselves if they have a tool to do that. Okay. So now, as we're talking about controllers, so one important thing we noted about them is that they need to have the same, need to be the same object, right? They can't consist of multiple objects. Now, another thing to note is that they shouldn't have any history. So history on a controller makes it more heavy, and we want to keep them very light. So once we are done with the controller, we want to go Edit, Delete by Type, History. And you can see all the history on the controller gets removed. Another thing to note is that if, say, you're creating a controller, you're moving it around, you're scaling it, now it's just how you want it to be. So you need to make sure that you don't have any transformations on them. So you always want to go to Modify and then Freeze Transformations. So if, for example, we're looking at this rig, you can note that it's very easy to set it back to default by just zeroing out all the controllers. I don't think I'm selecting the controllers that I moved, which is why it's not going to 0. But if you look at all of its controllers, you will notice that all of them by default are 0, apart from scale. Scale by default is 1. All right, so that's another note. So basically there are three basic requirements: that they should be one object, not have values on their transformations, and not have history. Everything else is kind of more of a preference. So they can have color, and that's always really good. Then they can have a different shape, and that's also great. But if they have, for example, values on them, then that kind of jumps out and feels like something is broken. All right, so now let's create a new scene again. All right, so with freezing the attributes, so we checked you can do that by going to Modify and Freeze Transformations. You can also change it through here. So you can right-click and go to Freeze, and then you can choose which attributes you're freezing. So in this case, we just want to freeze scale, so that freezes it. And now we can go to Edit, Delete by Type, History. Okay, so with attributes, by default, we have Translate, Rotate, Scale, and Visibility. But we can create our own custom attributes as well. So oftentimes when you look at rigs, you have, for example, IK-FK switch, which is its own attribute. Or you can have, for example, stretchiness on or off. For Morpheus rig, you have different clothes and different hairstyles that you can choose. Those are all also custom attributes for the character. So to create your custom attribute, you can hold down Control, right-click, and select Add Attribute in this menu, and you have to do it in the channel box, so inside here. So that will bring up this tool for creating an attribute. So the first thing we can set is the name of the attribute. So if, for example, we are creating an IK-FK attribute, we would probably put IK-FK here. Now, you can notice that this attribute has a long name and then a nice name. So by default, this nice name is hidden from us. So because it's being generated automatically from our long name. So the long name, so one thing you will notice is that it can't really have any special characters, spaces, so on. So it's so you want to avoid using those so that those attributes can be more easily accessible through scripting, for instance. But then the nice name will overwrite it to be more kind of visually pleasing. So if, for instance, we create our test attribute, and let's do add, you can see in this case it removed all the spaces. So the nice name that we see displayed here is just test attribute, and it also capitalized it. So if we are to say test attribute, so we put a capital A here, you can see it separated it into 2 words. So it created automatically a space because it figured that if we put the second one in the uppercase, we wanted that space. But let's say we have our test attribute and we don't want that space. In that case, we can overwrite the nice name and set this to just 1 word, test attribute. So that will be something like this. All right, so now we can make attribute keyable, displayable, or hidden. So keyable is the most common one. So that means that it will be shown here in the channel box, and we can set a key on it. So right now, we can change this test attributes, for example, from 0. We can set a key here from 0, and then here it can go to 10. And just as any other Maya attributes, it will kind of transition from 0 to 10 as we scroll down the timeline. Now, if we make it displayable, let's call it another test, you can see it has this gray part here, which means that we can change it, but we can't set a keyframe on it. So, oh, actually, it worked, key selected. So I don't think it will though behave the same as other ones do. Yeah, so you can see even though I changed it, it didn't work as you would expect the keyable attribute to behave. So you would usually have a displayable attribute if you know that this value is not going to change. So sometimes you have a separator between different attributes. You would make that a displayable one. Okay, and hidden, you usually wouldn't create, but it's the attribute that wouldn't even be displayed in the channel box. Hidden attribute, let's add it. You can see, so nothing got displayed here. So the only way to see it would be to go to channels. And then here we want to, oh, sorry, no, edit. And here we want to go to channel control. So here we can see all of the attributes that an object has. And you can see our another test got added here in the non-keyable displayed attributes. And that was the previous one we did. And then the non-keyable hidden attributes, there already are a lot that come from Maya here. But if we scroll, I don't remember what we call it, hidden attribute. Right, here it is. So they all positioned alphabetically, and this is the attribute that we created. All right, so now, so that's these settings. So now data type. So the data type can determine the type of the attribute, and all of these data types, all of these terms, they come from programming. So do you guys know any of these? Does any of these ring a bell?
I'm familiar with vector in imaging, but not so much broadly.
Yeah, so actually, so vector is an interesting example because what it means mathematically is very different from what it means in terms of programming, right? So when we think of a vector mathematically, we think of kind of the one that's symbolized with an arrow, right, with a magnitude and direction. So in programming, it's something completely different. Yeah, and so that's why, so I wouldn't actually look at the vector first. So the float, though, is the most common probably attribute that we see. And float just means that it's a decimal number. So it's any number that has a point. It can be negative, it can be positive. So for example, 0.5 is a float number, or 3.6 is also the float number. Minus 89 can also be a float number. So if we're creating a float, we can specify the minimum and the maximum. So for instance, we can have our attribute go from 0 to 1. And the default we can also set. So for instance, we can set the default to be 0. We can call this test float, add, and you can see it created an attribute that by default is 0. And then it can go up to 1, but no further. So if we try to set it to 2, it won't set to anything. But we can set it to any number between 0 and 1. So we can set it, for example, to 0.5. Now, if we look at an integer as a data type, so that's only whole numbers. So we can't set 0.5 for an integer. So 0 would be an integer, 1 would be an integer, 25 would be an integer, minus 87 will be an integer, but 0.2 is not an integer. So if we're creating an integer, let's call it test integer like this. So we can also set the minimum and the maximum, but if we are to set it between 0 and 1, it will only give us 2 values. So here we can set it, for example, between 0 and 10, and now add it. So now you can see as I'm scrolling through these, it goes between 0 and 10, but it doesn't give me any decimal numbers, right? So we can set 7, but we can't set 5.9. It will just go back to our previous number. And the same as with the float, we can't go over the maximum that we set. So we can't, for example, make 100, it will just truncate it to 10. And we don't have to, by the way, set the minimum and the maximum. So the default we do have to set. So by default, it's just 0. So if we don't change it, it will just stay that way. But if we don't set minimum and maximum, it will just go to as low as Maya allows us, and as far as Maya allows us. Okay, so then Boolean is another useful attribute. So it has just 2 values, true and false, or you can think of them as on and off, or as 0 and 1. So just 2 values, very light. So if we're to create it as our test attribute, you can see by default is going to be off, but we can change it. We can put 1 in here, and that will be on. So then if we put 0 in here, it will see it as off. So out of the default attributes that we have for an object, which attribute is a Boolean that you can think of?
It says visibility. Is that?
Yeah. Yeah, exactly. So this one, the visibility, it can be only on or off. So that's the Boolean. What about all of these attributes? Well, let's say just if we take one of them, what is this attribute's type? Translate X.
I'm assuming they're all float.
Yeah, exactly. So they can be any decimal number. So we can do, for example, 0.4. So that means they're all floats. Okay. So as we go further, we can also see there is an enum. And enum in programming, kind of, if we're setting it in programming, we're setting separate options, kind of separate, almost separate variables for that we can then change to. So here we're kind of simulating that. So you might notice sometimes, let's say you have a rig and you have an ability to switch between different mesh modes. So you have a low mesh, a mid mesh, and a high res mesh. So we can do something like that with an enum. So let's call it resolution. And then instead of green and blue, so green and blue are the two values that we're given by default, but we can change them. So this one can be, for example, high. This one can be medium. And then we can create a separate one. We don't see it right now, so you have to select this invisible spot. Now we can call this one low. Okay, so now that we add it, you can see we can change it here. So medium, low, high. So whenever you have those drop-down menus for selecting options in the attribute, that's usually an enum. Okay, so now the string is a data type that is just a collection of characters. So those can be any characters, so both letters or numbers. So if we're to create a test string, we can insert any word with any numbers in it. So the interesting thing about strings is that it won't be displayed, or at least it didn't used to be displayed in the channel box, even when it's keyable. Let's see if it's still the case. Yeah, so you see, even though we created an attribute, we don't see it here. So that's because to actually see the string attribute to create it, we have to go to the attribute editor, and I thought it was under extra attributes, maybe. Oh, this is shape. There, NURB circle, extra attributes, and you can see our test string is here. So we can now type something in here. So this is useful if, for example, each object that we create needs to have a specific tag, for instance, or specific ID number, or something like this is important circle. So now nobody will know that this object is an important circle, but if we write a script that looks for all of the important circles in the scene, it can find them through this string. So that's one way it can be used. All right, so now and now vector. Right, so vector, as we talked about before, in mathematics and in programming is kind of a different concept. So in here, it just means a collection of 3 floats. So if we are to create a test vector attribute, it will create 3 attributes, and 3 of them will be floats. So the way kind of translate or rotate or scale works, so they're probably under the hood, they are vectors. But it doesn't matter to us because we just care about them as float values. But we can create our own similar attributes by creating a vector. All right, any questions about attributes so far?
Is there a reason you would pick an integer over a float?
Yes. So one reason would be that it's lighter. And another reason is that sometimes you don't want to give an animator an ability to insert decimal numbers. So sometimes you only want them to set specific whole numbers. Right, without specific example, it's probably not a very good explanation, but I can't think of anything that could be in a rig right now. If I think between now and next week, I'll let you know. But there are cases when you don't want them to do something in between 0 and 1. For instance, you just want to set specific values. Let's say you want to give them an opportunity of how many joints can be displayed, for instance. And let's say we have an attribute, and as we change that number, the number of joints displayed changes too. So for something like that, you wouldn't want to have a float, because you can't have 3.5 joints, right? You can have either 3 or 4. So for something like that, you would use an integer. All right. Now, if we created an attribute, but then we want to change something about it, we can edit that attribute. So let's say we have this test float, but we want to change something about, say, the minimum and the maximum. So we can do the same thing, hold Control, then right-click, and we can go to Edit Attribute, find our test float. Where was it? There, test float. And let's say instead of maximum of 1, we want a maximum of 5. So we can do that, close it, and now we changed its maximum. We can also, if we are unhappy with our attributes, we can delete them. So we can just select them and right-click and say, Control, right-click and say delete attributes. Right. Oh, I wonder why didn't these get deleted? Yeah, that's odd. I guess we can't easily delete vectors when we create it. I never knew about this. Okay, something I might look into later on. All right, so yeah, so that's how you create them, edit them, and delete them if you need to. Okay, any questions about attributes? No? Okay, good. So yeah, so now you know how you can create your controllers, how you can create your custom attributes for them. Now, if, say, we have a controller and an object, so what are the ways that you guys know in which we can connect this object to this controller? So how can we make it that the controller actually controls the object?
Maybe parented?
Yep, parenting is a good way. So we parent the cube to the controller. So now we can move controller around and the cube will be following. Parenting is a pretty light way, so that's one way of connecting them. What other ways can you guys think of?
Maybe group?
Group both of them. Well, then it won't allow us to control it with this controller, right?
Okay, right. That script which we were writing in the beginning of the class.
Yeah, that's one way. True. So that's a bit of an odd one, but that sometimes is used in rigs. So we can select the shape of the controller. select the cube, and now we can run parent-r-s, and that will make the shape of the controller part of the cube, right? So now if we move this controller around, if we grab the controller, it will grab this cube with it. So this way is sometimes used because it's very light. So if you want to make your rig as light as possible, you could use this way, but it has some downsides too. So it's not very commonly used. What other ways can you think that we haven't talked about this in this class, but we talked about them in the previous class, in the Intro to Maya class? So for those of you who've taken the Intro to Maya class, you learned about another way of connecting them.
Constraints?
Yes, exactly. So we can also constrain. So if we, let me undo this shape parenting. And let's freeze the scale. Now we can delete history. Yes, so we can select the controller, select the object, and then we have all the different constraints to choose from. And in a bit, we'll talk about the difference between them. But if, let's say, we create a parent constraint, now we can move a controller and the object will follow. What other ways you can think of? So something that we kind of touched upon previous class.
Would connecting the nodes do anything?
Yes, so not specifically the nodes, but the attributes, right? So if you remember in the previous class, we connected the attribute of one cube to the attribute of the other cube. You could technically do that with a controller in the cube too. So if we select both of these, we go to Windows Node Editor. So we can select, for example, translation, and connect translation of the NURBS curve to translation of the cube. So you can see it shows now the arrow that helps us to understand that this controller is controlling this cube. Right, so now if we try to move it, the cube's translation will change as well. So that's also a way. Okay, I don't think I deleted the constraint. Okay, can anyone think of anything else? Yeah, I couldn't think of anything else either. I have just those four. Maybe there are some other ways, but I can't think of any. All right, so let's talk about constraints. So constraints are probably the most common way of connecting something to a controller, and that's because they provide us with so much functionality. So yes, and a lot of this functionality we can't achieve with simple parenting. So one thing, for example, is that we can have multiple objects for constraints. So this probably won't, this won't help us with this cube, but as a feature, it can be very useful. So let's say we have, excuse me, let's say we have 3 of these circles. We can constrain all 3 of them. Let's say constrain parent. And as a result, sorry, I selected them in the wrong way. Like this, constrain parent. So as a result, if I move this controller or I move this circle, this middle one will move right in between these 2. So it won't follow it exactly. It will kind of move midway between them. So it will kind of follow both of them, but halfway. So that can be a very useful feature. Now, okay, another one is that we can overwrite the parenting behavior. So if, say, we have this cube in its own hierarchy, so kind of like your robot was in its own hierarchy. So let's say this p cube 1 is parented to p cube 2. So now if we move around the p cube 2, p cube 1 will be following. However, if now we're to create the constraint around this cube, constraint parent, now if we try to move around this cube, you can see this one won't be following because constraint overrides the parenting. And this can be very useful if we're dealing with the hierarchy in the rig. So you can have a separate hierarchy for controllers, a separate hierarchy for your joints. All right, so another great thing is that if we are connecting things through constraint, they exist separate in the hierarchy. So these two objects are parented, for instance. So if, for example, we want to make this one invisible, this one will become invisible with it. So something like this. With the controller, however, with the constraint one, however, if we turn it invisible, it will keep everything else the same. And another reason is that it's just nice to have them in its separate sections. So we can have a group, for example, where all our mesh is. We can have a group where all of our controllers live. And so it's more organized in the hierarchy. All right. So now, once we do create the constraint, you will see that all of these attributes turn to blue. Do you guys know what it means? Well, what it means for us that they turn to blue. So it basically means that they have incoming connections to them. And so what that does is it means that we can't now easily set keyframes on it. So we technically can, but that's not very advisable because then it creates a weird transformations. So actually before in Maya, you couldn't even set keyframes at all. Now you can, but you still wouldn't want to do that. And that's important to remember that because whenever we create a constraint, it's okay if, for example, the mesh here has some incoming connections, because Animator is not going to be touching this mesh. Animator is only going to be moving the controller. However, if, say, we have another controller and we want this one to be connected to the first, we don't want to create a constraint, because if now we're to create a constraint, this controller won't be animatable anymore, right? So if we have a situation like this, if we have two controllers and we want to connect them to each other, how can we do that so that we don't have incoming connections here? Does anyone have an idea?
Go to node editor.
Okay.
And connect in the same way.
True. Yeah, you could connect translation and rotation, but that's a bit tricky because that connects just the values of the attributes. There's an easier way. How can we more easily make them follow one another? We can just parent them, right? We can parent one to another. The problem here is, though, is that the values might change depending on the parenting, depending on the parent. So in this case, it won't change, but in this case, this one's translation values will change. Now, what if, for whatever reason, we need to connect these controllers specifically through constraints? How could we do that? So that we don't get any incoming connections. Any ideas? The trick would be kind of similar to the fingers of the robot.
Create a null group.
Yeah, exactly. So we can create a group over this NURB circle, and then we can connect them together like so. So now this group has connections, but not this circle. So now we can move this around, but and this circle can be moved around as well. Okay, now so separate hierarchy. Okay, so now let's look at what kind of constraints we have. Let's create a new scene, and for that demo, let's create 2 cubes. So, so as a reminder, we first select the driver, then the driven, then we go to constrain, and here you can see there are all these different options. So parent constraint we just took a look at. So it acts very similar to parenting. So if we move this object, this one will follow. If we rotate, this one will follow as well. And if we scale, this one will change its position, but it won't scale on its own. So that's kind of one little difference to keep in mind. So that's the parent constraint. Then we have point constraint. So point constraint is responsible for translation. So if we're to translate this cube, this one's values will become the same. Okay, so right now you could notice once I created the constraint, this cube snapped to this one. So that's because it wanted to match its position exactly. So oftentimes we want it to follow, but with the offset that already exists. So in order to preserve that offset, we can go into options and check maintain offset. So if we add the constraint now, we can, so you see it didn't snap, and we can move the pcube1, and pcube2 is going to follow. So because we're only connecting the translation, if we're to rotate this cube, this one will stay in the same place. So that doesn't change it at all. And the same thing with scale. It also doesn't change it. Okay, you can also note that when we're creating constraint, it actually creates a separate constraint node that is in this pcube2's hierarchy. And if we're to look at them in the node editor, you will see it. So let's check the connections between them, and you will see it in between these 2 cubes. So the translations of these cubes are connected through the point constraint. And if we now look at this cube's attributes, you will see the translation ones are blue, but the rotation ones are not affected. So we can still have animator rotate this cube, even though they can't translate it. All right, so that's point constraint. And then I'm going to go to constrain orient, and that you can probably guess it just deals with rotation and not position. So we can rotate the cube, the other one will rotate with it, but if we translate it, this one will stay at the same place. So what is the difference? Did you guys spot the difference from when we did parent constraint and when we did orient constraint? What is the difference in rotation between the cubes?
With the parent constraint, they both rotate from the pivot point of the parent.
Mm-hmm. Yeah, and with
the orient constraint, they each rotate from their own pivot.
Yeah, exactly. Mm-hmm. Yeah, very good observation. So these two are connected through an orient constraint. So if I rotate one, the other one will rotate around its pivot point. But with these two, they're connected through parent constraint. So if I'm to rotate it, the other one will rotate around the first object's pivot. So that's also something to keep in mind. So if you do point and orient constraint on two objects, that's not the same as if you do a parent constraint, right? Okay. So now, next one is a scale constraint. So can you guys guess what the scale constraint will do?
Resize the object?
Yeah, exactly. So it would be exactly as if we change the scale of two objects. And here you also want to note that it's different from parenting or from parent constraint, because again, they will change size from their own pivot points. All right, so that's scale. And then aim constraint. So aim constraint is an interesting one. And the options I want to pay a bit more attention to. But basically, if we do it, we just create an aim constraint by default. What it will do is it will aim this object to wherever the position of this object is. So it's like this one is looking at it. Can you guys think of where in the rig we could use this feature?
In the arm, for example.
In the arm? So like the arm pointing somewhere? Well, so that wouldn't be very common, right? Because with an arm, we can just grab parts of the arm, and with an IK controller, we can move it, right?
How about the eyes?
Yeah, so that's a very common one. That's a very common implementation of this constraint. So if this was an eye, this could be a controller. So sometimes you will see there's a controller in front of the character, sometimes called an aim controller or eye aim. And we can, if we move that controller around, the character will look at different places. So that can be very useful for an animator, where they don't have to animate each individual eyeball. They can just have a character look somewhere specific. Okay, so that's an aim constraint. Now, so a pull vector constraint we will look at when we talk about IK rigging. So it's a very specific constraint for a rotation of the IK handle. So that one we'll take a look at later. But other than that, so these are the main controllers. Usually in the rig, we will use parent, point, orient, scale not so much, and aim for like specific things like the eyes. Sometimes the head might get a name constraint, but not that often. but it's mostly things like the eyes. Okay, any questions about constraints? All right, so one more note about attributes that I forgot to mention. So once, when you're rigging and when you have, say, your controller and you're done with rigging, sometimes certain controllers will have, you will want Animator to use only specific attributes. So let's say this controller can only be rotated and it can't be translated or scaled or changed visibility. So in that case, you would want to hide these attributes from them. And the way you can do that is you want to right click, and here you can see there is hide selected, lock selected, and lock and hide selected. So you usually want to choose the lock and hide selected so that they can't accidentally change it. So you can see if we choose that option, now they can't even move this controller. So now this controller can be only rotated. So if, for instance, we are doing an orient constraint here, and we know that this cube can't be moved, we would just, then we would make sure that only the rotation is available. So we would also want to lock and hide selected here. Now, the reason why we lock and hide and not just hide is that if we are to try and hide, let's say just this translation, the animator can still translate it, right? Because it's not locked, it's still available to them. They just can't do it through the channel box. So that would be the reason for that. Now, if let's say you hid the controllers, but now you want to, let's say you made a mistake or you change your mind about this controller, you can go to Edit, Channel Control, and you can get back those attributes. So let's say you want to get back translations, we can select the translate attributes and click Move. So now they're being moved to the keyable attributes, and keyable attributes are being displayed in the channel box. So as they go back, because we locked them, they're being shown as locked. So to unlock them, we can select it and right click and pick Unlock Selected. So that will make them keyable again. All right. Yeah, and sometimes in the rigs, you will see controllers that only have user-specified attributes. So if, say, we create another test attribute, oh, well, not this one, not the vector, something more normal, like float. Okay, so say we have a user attribute, so it can be anything. Let's say we want to control visibility of the whole rig, or let's say we have a controller that just has parameters for something, for various things in the rig. Let's say it changes textures or something like that. So we can just hide, lock and hide all the other attributes, and then this controller will be responsible just for our specific attributes. So that is not that unusual in the rigs, that you will sometimes see things like that. Okay, so yes, that's all I have about controllers, connections, constraints. Any questions on any of that?
If you do the thing where you lock and hide, like for example, the translation of a controller, but let's say that controller is on like the elbow, but that's, you know, that's part of a series of other controllers, and the controllers move with the previous body. So like if you rotate the shoulder and the elbow moves here, if you lock that transform constraint, well, it'll still take the incoming data, right? So it'll still move in space, you just can't move it yourself.
Right, exactly. So it will still follow its parent, right? So that will still be the same. but you won't be able to change it. So actually, let's recreate that example. So let's say we have, let's do it in a new scene. Let's say we have an arm of the character, so something like this, right? And we now want to create our controllers. So we have a controller here, but let's make it here. And then we have a controller here. We want to freeze their transformations and also delete their history. And now, so let's say they are parented to each other, right? So let's group this controller. Let's match the pivot points of the group. So now it's the same as the controller. So now we can parent it here. So now we have a situation where we have controllers around our arm. And when this one is moved, right, rotated, this one is moved too. So then if this one is, say, controlling this piece of geometry, and then this one is controlling this piece of geometry, our arm will move together. So let's say we can pose our arm like so. And then, now let's say we don't want to give Animator an ability to translate it, right? So we would lock and hide translations. Where is it? Lock and hide. And the same thing with scale and visibility. So now we can't move it, right? But we can still rotate this controller all the same, and this controller will follow. So we can still pose our arm the same way. It just, we would do it through rotation and not through translation. Does that answer your question? Okay, great. Any other questions or thoughts? No? All right. In that case, let's look at the homework for next time. So you will find in your materials at here, you will find that one of the models you have is a Ferris wheel. So that's your rigging assignment for next time. So you can see, similarly to the robot, the pivot points are kind of all in different places, or sometimes all of them are at the origin. So you want to create a rig that will make sense for this Ferris wheel. Let me actually bring up, I put that assignment down in writing. So basically, I want you to imagine kind of yourself as if you're a rigger and the modeler gives you this Ferris wheel, and then an animator needs to use it. So it's kind of up to you which controllers to use, but then they tell you that it at least needs to have 2 main controllers for the basic functionality. So one part for functionality is to move the whole Ferris wheel around, right? So to position it somewhere, to rotate the whole thing, to scale the whole thing up and down. So that's one functionality. And the other one, the main thing, is that it needs to rotate the wheel. Now, as animator is rotating the wheel, you also need to think of what kind of functionality to give them for the cabins. So maybe you'll create controllers over each of the cabin and have them move. Maybe you want to create attributes that you change and then the cabins move. Maybe you want to try both of those. So both the attributes that, for example, one attribute controls all the cabins, and then there are controllers for separate ones. So that will be a bit tricky. So you'll have to think of how to implement that. But that would be a cool feature that any animator would be thankful for. So yeah, so basically you have to kind of imagine yourself trying to deliver the best way to animate this object. So once you're done with that, you want to create a video in which you want to just do a screen recording where you kind of move each part, right? So you show how the base works, how the wheel works, and show how you can control each of the cabins. So since we already looked at controls, you don't want the animator to have to touch geometry. So animator needs to be able to create all of their animation through just using controls. So make sure you give them that ability. And then also at the end, you want to create a play blast with the Ferris wheel kind of rolling to show how it all looks. All right, so basically you want to upload one my binary file and two video files. So one where you're showing how the rig works, and the other one with the animation of the wheel. Does that make sense? Any questions? No? Okay. Well, if you get questions before the next week, make sure to send me messages. I will sometimes miss them, but I try to pay attention to the Anim School website and make sure to check them. All right. So that's it then for today. There's a chat message. Okay, yeah, Hunter, oh yeah, so another note, so for a screen recording, so you can do some research, find whatever works best for recording your screen. So some things that I've used in the past, one is OBS Studio, so you can do your recording with that. That's a free software. I don't know if it's open source or not. And then there's also one called Active Presenter, which looks like this. So that one can also be useful for kind of demoing. It also allows you to kind of talk over it, which is not really important for us, but you can also use it. All right, so hopefully that will help. So those create files that are kind of manageable size. You can then kind of scale them down with any kind of compressor, like the one I mentioned before. I always forget what it's called. Something like Party Time, or what is called Handbrake. Yeah, Handbrake. Or there are lots of other compressors online. There are even websites that allow you to upload a video and then you download a compressed one. So make sure you find a way in which you can upload. If you upload MP4 or MOV, then we can look at it in Sync Sketch. So that's always a preferability of mine. Okay, so that's it then. Any final questions? No? Okay, great. In that case, I'll see you all next Tuesday.